Hello everybody, good evening. So recently I have been assigned a project that is a binary classifier for selecting whether an image is either top or just a jeans. So this was a project assigned to me, and today I'm going to solve this very basic problem, and that is binary classifier. So we are going to take reference from similar project that I found on GitHub. Just wait a moment, I'm showing you project that I got. Okay, it's here. Okay, so the project name is pizza versus soft drink. So this is also a binary classifier, and what here they have done, they have classified between various uh, two things that are either one thing is pizza or it is soft drink. So we are going to do a similar project. So starting right now, first rename the project. What top versus jeans. Yeah, so that's our main motto. So uploading the data set. Our dataset consists of, let me show you, training dataset and test dataset. And training dataset consists of 1,000 images. No, training dataset consists of 6,000 images of top and 6,000 images of uh, genes. Okay, you can see here. And the test dataset consists of 1,000 images of test genes and 1,000 images of top. So we have divided the image in 6:1 test data to. Okay, so moving forward, what we got here. So I think I have uploaded the dataset. Okay, so the dataset is being uploaded. So moving forward until that. Okay, so here it is being currently uploaded. Okay, it will take some time. So what we are going to implement, we are going to implement a CNN model, convolution neural network model, and it will be in sequential model. So the process will be continuing, and we need to modify certain changes, like we need to use graphics for faster computation. So yeah, change runtime type. Okay, so once the file is uploaded, we will change this to an applied hardware acceleration, and we will use GPU for hardware acceleration. This will surely increase the decrease the time required for model training. So taking the inspiration, like copying few codes. This way, we don't need to connect our system to our drive because we are just uploading the dataset directly. So every time when you are going to run this, you have to upload the dataset directly. Moving to our next file. So we need to import certain things like from Keras, pre-processing image data generator. So this will generate the image dataset. Okay, so I will tell you later what is the use of this thing. Okay, I think assignment zip is uploaded. Just wait for it to being uploaded. Okay, so moving forward. Those are most things we have to upload, so just write it down here. That's it and nothing else. Okay, so what we need, just copy this code here. Here, I will make you understand. Uh, plus, plus. So what we are doing here, we are just declaring the size of our images that we are going to provide for model training and for model testing. So we are taking images of 64 by 64, and so we have to change this 64 by 64. So once the this zip file is uploaded, we need to first we need to extract data, unzip this, and then we need to uh, show here what data set we are using and where it is, and give it its path. Okay, so I think it's about to complete. So we need few things like extracting, unzipping the file. So we need this code. Okay. Okay. So we need to we like to get here. So you can. Okay. How about this? So, so okay. So this is uploaded and copy its path. Copy path and put it. Just replace the value and just first run this, and you are importing various data's what you say functions. Yeah, it's okay. Our this thing is imported. Now unzip it again. Unzip the data set that you are going to use. Just the process started. Before that, there is some error. I don't know what that. Just let's check. So we are going to use, let's say, so our library and this whole module will be reloaded. We need to change few things. Oh shit, our data set got deleted. That's the bad. Okay. Hmm. Okay, so I have uploaded the file to my Google Drive and linked my Google Drive to my Colab. Now, and I have extracted all the required zip files and images required for training purpose. So now just copy the address of the training data set. That is, this one is the address. Just copy the path and paste it. That's nothing else you have to do. And then for validation, what is your validation thing? Just to copy the path, that is our testing path, and just copy and paste it. Yeah, that's it. Just add here a dot. This will state that you are starting from currently from here. Now the number of training samples that we are taking is 1,000. No, it's actually 6,000. And the validation samples that we are taking is 1,000. Okay, so we are going for 50 pots and batch size that we are taking are of 16s. So moving forward, what we need to do now, we have our data set, and next thing we need to do. So we need to define the shape here. Just this will show the shape. Okay, so just run this code. Okay, no problem in running this. And after that, run this. Okay, so that was the easy part. Now we are going to generate a data set. Okay, so this is the image data generator that we have imported. Let me show you. Yeah, we have imported from Keras preprocessing.image, and we are using that function, and we are rescaling that for computation. If you are not rescaling that, and it would be quite difficult for machine to compute. So we break down that from larger chunk of memory spaces to just from 1 to 255. So that will be breaking into smaller pieces, so that will be easy to compute because it will be just between 0 and 1. Okay, so next part would be like yeah, we have defined how to generate a data set, and now we are going to actually generate a data set. We are converting this, and we are just using binary conversion, binary differentiation. So this part. Okay, so here what we are doing, we are using flow from directory, and whenever the images come, then it is converted and make a batch size of 32, and that's it. Now we have our data set. Again, we are rescaling this. So copy this. Okay, so next step is okay, training the defining the model, how our model is going to be. So we are using CNN for this purpose. And okay, so they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They are using actually more than 10 or 12 layers. Okay, so that was it. And this is our fitting part of our, no, this is the compiling part. And after this, we will fit our model according to our need. Okay, so after that, we will fit our model and here's code. Okay, so just run the previous ones. If there is some error, then we can fix that now. As yeah, I was talking about this thing. So no such file directory dot assignment dot train. Okay, so let's see. Just remove this dot. Now run this, again run this, and then this. Hopefully the problem will be solved, and yes, problem is resolved. Moving forward, so they found 2000 images which belong to the testing data set, and as the model we just define our model how it will be, and then once it is defined, then move forward and compile your model. Okay, so this is the basic structure of our model, and these are various layers and various uh, filters, or you can say that we are applying various methods. So after that, fitting the model, this is the crucial point. So this will take a lot of times according to this system. Okay, so this is taking way beyond. So I'm pausing the video, and once it is finished, I will resume.